Hi, 7th graders. We are going to go over 9.2 today. So what I need from you is your book open to page 364 and your notes that I have made for you on 9.2. We're going to be talking about surface area of pyramids. Now remember, the difference between a pyramid and a triangle is a pyramid is a three-dimensional shape made up of triangles, and the base doesn't have to be a triangle. The base can be a square, a rectangle, it could be a triangle, but you'll see that there's a lot of different types of pyramids. Now, something called a regular pyramid is a pyramid whose base is a regular polygon. Remember, a regular polygon just means that all sides are the same. So, for example, a regular polygon might be something like a square, because all sides are the same length, right? A regular polygon might be a pentagon, whose sides are all the same length. You're going to watch me draw a terrible pentagon that sides do not look like the same length. But what I need you to understand is that a regular polygon, a regular pyramid, is a pyramid that has a base of a regular polygon, okay? The base is the part that the pyramid sits on. So if you look at this picture, the red part is the base, okay? That's the part that it sits on. Here is the base right here. In your notes, I have taken out some things that we need to label. So base I kept in there because I thought that was kind of important for you guys just to know base is the bottom, okay? The next thing we need to talk about is the slant height. I didn't take that one out. Slant height is like the height, but it's like to a slant, you know what I mean? So if I just looked at this triangle, like totally unfolded, it wouldn't really be a slant anymore. And it's right here. See that? So the slant height is the same thing as that triangle's height. Okay? Now let's go ahead and start labeling the inside of this shape. So I've got, this was the slant height. We just said that. I'm going to grab a red real quick. Slant height. Okay? So slant height is that red line when you fold it out. And now let's talk about the blue triangles. Those actually have a name on every pyramid, and they are called the lateral faces. The lateral faces. Lateral faces. Lateral faces. And now let's talk about how I would find the area of a pyramid. I'm going to go ahead and write the formula. I'm going to write it up high right here, nice and big, so that when I'm looking for it, I can find it. Now, I'm going to use S to represent surface area. It's going to be a big capital S. Capital S is surface area equals, here's how you find the area of a pyramid. I want you to first find the area of the base. I'm going to use red since our base is red in the picture. So it's area of base, and we're going to use a big capital B for that. Okay, so B stands for the area of the base, not just the base. Like, it's not a single number. It's the area of the base. You're going to take like the length times the width, right? So it's area of the base times areas of the lateral faces. And I'm going to go ahead and just put, I can just write it too, area of lateral faces. Okay. Surface area equals area of the base times the area of the lateral faces. Oh, sorry, I didn't mean times. I meant plus. Let's fix that. Boop. Plus. That makes more sense. Okay, so let's go ahead and put this right to work. So let's go over to this first example. I want you to find the area of this shape. Now, they were very kind to us. This is a 1, 2, 3, 4, 5. This is a pentagon. It's a regular polygon, which means I can use this formula to find the surface area. They told me what the area of the base is. That way we didn't have to try to figure that out. So the area of the base is this. Now I need to find the surface area of the entire thing. So here's what I want us to do. I want us to write the formula at the very top. We're going to say S equals surface area equals area of the base plus, I'm going to use an abbreviation for areas of lateral faces. I'm going to say AL for area of lateral, okay? I could even say ALF. Let's just do that. ALF, ALF. That's funny. I like that. Surface area equals area of the base plus area of the lateral faces, ALF. Let's go ahead and plug in some numbers. Do I know what S is? Yes, I do. Oh, sorry. No, I know what B is. B is the area of the base. I know what that is. So I'm going to go ahead and plug that in. So I'm going to say S equals, and then I'll plug this in for B, 440.4 plus, now I got to find the area of the lateral faces. Remember, if I opened up this pyramid, I'd have a bunch of triangles. How many triangles would I have? Well, that depends on how many sides my base has. How many sides does the base have? 1, 2, 3, 4, 5. That means when I open it up, there will be 5 triangles coming out of the sides. Just like similarly over here, there was 4 sides to the base, and do you see how each side had a triangle coming out of it? There was 4 over there. There's going to be 5 over here. So technically, I just need to find the area of one of these triangles and then multiply it by 5, because there's 5 of them. Now remember, the area of a triangle is the base times the height divided by 2. I know the base is 16. The height is 20. All I need to do is take 16 times 20. And then divide that by 2. Okay, so when I take 16 times 20 and then divide it by 2, I got 160. So I'm going to write over here 1 lateral face equaled 160 millimeters squared. I have 6 faces. Remember, or sorry, 5 faces. I have 5 faces. I've got the one right here, the one right here, the one right here, there's one back there, and there's one back there, right? I have 5 of them. So if I have 5 faces, I need to take 160 times 5. And that would equal 800. Now don't think that's your final answer. That's the ALF. Remember the ALF? That's the area of the lateral faces all together. So I'm going to go and plug in my ALF, and that's 800. Now I can find the surface area total. I got to take 800 plus 440.4. Okay, when I do that, that equals, ooh, that's a biggins. Did I do it right? No, I times it. Silly me. 800 plus 440.4. That's much better. 1,240.4 millimeters squared. Ta-da. And then we always circle our answer so that we know that we finished it. Okay, so here's the big thing we gotta remember. S equals big B plus ALF. S is the surface area of the whole shape. Big B is area of the base. ALF is the area of the lateral faces altogether. I'm going to go ahead and write all of that right here in this little space that I have, because I think it's important for us to remember that all of these things actually mean something, right? Okay, and then I'm going to take a pencil and I'm just going to go and write what each of these things are. This is the surface area of whole shape. Big B is the area of the base. And then ALF is area of lateral faces. Okay, now that we have that little cheat sheet for us, this should help us for the next one. Let's go ahead and look at this guy. This is a composite figure. We've got two things going on. I've got a pyramid on top of a cube. So let's do the first thing, or sorry, this isn't even a cube. Oh my gosh, that was almost a big mistake. That's not a cube. This is 5 by 4. Woofda. So you know what? Let's find the area of this rectangular prism first, and then let's talk about the pyramid, okay? So off to the side, I'm just going to go ahead and say prism equals. We're going to do prism first, okay? The side that's facing me is 5 by 4. 5 times 4 is 20. So that means I have a front that's 20 and a back that's 20, right? Now let's do the next side. This side on over here is 5 by 4, so that's 20. This is also 5 by 4 then, so that's another 20. Now let's do the top and bottom of this thing. It's a 5 by 5. You gotta be careful, it's not 5 by 4 again. 5 by 5 is 25. And there's a bottom. How I know that I didn't miss any of my sides is I should have 6. 1, 2, 3, 4, 5, 6. And there are 6 sides to that little rectangular prism. Add them all up. 5 and 5 is 10. 2, 4, 6, 8, 10, 12, 13. Okay, so the prism is 130 feet squared. Let's try to remember that. Now let's go find the pyramid. Now let's remember, pyramids surface area equals big B plus ALF. Oops, I wanted that to be black. And then I want this to be blue. ALF. Okay, so let's go plug in the things we know. I can find the area of the base. Remember, that's going to be the blue thing. Area of the base. So the base is 5 by 5. Remember, we're talking about this guy right here. 5 by 5. Ooh. You know what I'm just realizing? I'm realizing that if I'm talking surface area, I'm talking about like area that's exposed to the shape, that like if I needed to find out how much construction paper I needed. If I'm finding the area of the base for this pyramid, is that even exposed? Like, is that a part that I would have to wrap with wrapping paper? Or is that a piece that I'd have to wrap with construction paper or paint? It's not. I don't need the base. In fact, I don't even need this face at all because it's not out in the open. It's not a part of like the surface, which means won't that change my prism's surface area? Because it's not a surface that's exposed. It's hidden. It's being sandwiched together. So I actually need to go back up here to the prism and get rid of one of these 25s because that isn't a part of the surface. It's part that's like glued together. It's not something I would need to cover. So let me grab my eraser. We got to fix that. Okay, so that's really going to change a lot of this. So I'm going to go sneak this back up here. Okay, so now this is going to be 5. Oops. 5. I'm going to get rid of my 1 that I carried up there. 2, 4, 6, 8, 10. 105. Okay, well now that does change things. Big B, I don't want it. And the reason why I don't need this is because it's not a surface that's exposed. I don't need it. I do, however, need the area of the lateral faces. Now, to find the area of just one of them, remember it's a triangle. I need the base, which is 5, right? And the height, which is 6. 6 times 5 is 30, but I need to divide it by 2 because it's a triangle. 30 divided by 2 is 15. 15 feet squared is 1 triangle. I have how many triangles? Well, it looks like the base is a square, which means I will have 4 of them. I have 4. So I need to take 15 times 4. 15 times 4 is 60. Oh, that was easy. 60 feet squared. Okay, so just as a little quick recap, I have now found the surface area of just my rectangular prism without my top bit, and that was 105. Then I found the surface area of all the triangle pieces of my pyramid, and that is 60. So now my final thing I need to do is I need to take 105 plus 60. 165 feet squared. And then we circle it. Wowza. That was quite the problem. I'm glad that we had like that last second thought of like, wow, we don't actually need that, because it does change everything. I only want the pieces that are out exposed to the air. Okay, last example. This is a triangular pyramid. Its base is a triangle. So what I have done is I gave you guys the picture that they said, and then here is the net of this triangular pyramid. It's spread open, but I got rid of all of the dimensions, and the reason why I did that was because I want to be able to see if you can tell which dimension goes to which. I know it's confusing when there are lines are all crossing one another and there's arrows going everywhere, but I think it's important for you to be able to see who is actually who. Now the base in this situation is this guy right here, okay? Now when you open it up, that would be him. It's pointing right here. It says 8.7 and it's pointing to this height, which means the height right here is 8.7. So let's grab our pencil and let's fill that in. This is going to be 8.7 for the height of the base, okay? Now, I'm also looking at the rest of these dimensions. It says this is 10 and the slant height of the lateral face is 14. So over here, I'm going to say that the slant height of the lateral face was 14. And then I'm going to say where it has like a kind of a blue with an M right there, that's where we're going to put 10. So that means this is 10, this is 10, this is 10. This is 14, which means this would be 14, and this would be 14. This is 8.7. Okay, now that we've done that, we can go ahead and use our formula we just learned. I've got S equals big B plus ALF. Okay, don't forget what all these things mean. S is surface area. That's what I'm trying to find. Area of the base. I'm just going to find the area of my base and plug that in for that. Plus the area of the lateral faces. Let's go ahead and plug in some things. I'm going to plug in big B first. Big B is going to be, to find the area of this, you would take your base times your height. So 10 times 8.7. Remember, anything times a 10, you just move your decimal over once. So 10 times 8.7 is 87. But remember, that would be for like, you know, a rectangle. We have to divide it in half. So I'm going to take 87 divided by 2. Okay, so big B, after taking 87 divided by 2, is 43.5. Now I need to add it to ALF. Okay, we need to find the area of the lateral faces. Let's do this one right here, since I know that its slant height is 14. It's going to be 10 by 14. Remember, whenever you times it by a 10, you move the decimal over one place, so this would actually be 140. But I do have to divide it by 2. 140 divided by 2 is 70. So I know that the area of one of my triangles is 70, and I have 3 of them. So I need to take 70 times 3. After taking 70 times 3, I get 210. Now all I have to do is add it up. 210 plus 43.5 equals 253.5 meters squared. And there you have it. Surface area of pyramids. Surface area equals area of the base plus area of the lateral faces. I'm glad that you guys filled out these notes with me. Remember, if you need to pause the video, go back in the video, anything, please do. These notes need to be filled out. I will check them to make sure you actually filled them out when I come back, because I've been having students not fill them out with the video, even when they're in school. So please fill these out with me. We do not have a bell ringer for today, and the reason why is because I gave it to you yesterday. So all I need you to do is fill out these notes, and then you are set. No bell ringer, no exit ticket. All right, bye guys.